Good morning, biology. Miss Wright is here, and we're going to go over the biology of the current COVID-19 pandemic here. And why is this important that we're going to talk about this? Well, it is directly affecting each and every single one of us. Otherwise, we would be having this presentation in our classroom right now. It's so important for us to talk about this. Mr. Spicer and I wanted you guys to understand the background of it and everything, and so we put this together to present to you guys, and hopefully everything that you have questions about COVID-19 gets answered in here. But our plan for it today is we're going to go over the biology of the current COVID-19 pandemic. What do we know about COVID-19? What is COVID-19? How did COVID-19 arise? The spread of COVID-19, the infection rate of COVID-19. COVID-19 doesn't pertain to me. COVID-19 prevention methods, and any other useful information we have about COVID-19 along with that. Our objective with this today is that you can take away more sound understanding of COVID-19, and you can do well in this isolation time that we have, this quarantine time, and not feel like there's so many unknowns, and that you just have a better understanding of COVID-19 in general. Okay, so let's begin with COVID-19, and what do we know? Well, first of all, things are constantly changing with COVID-19. We are seeing changes not only every day, but almost on a 5-6 hour basis, and how things just are rapidly progressing with different things in aspect of we're closed with school longer. Now they're not allowing children under 16 into certain stores. They don't want to do certain things like that and really limit the social distancing and everything. Like the playgrounds in Laramie are fenced off and closed and everything. So, this is changing rapidly as we see it. So it's important to keep checking reliable sources. We're going to include these links on Schoology for you, so you can always check them and see if there's any updated, but make sure if you are checking sources that they are reliable sources. That's the most important thing you can take away from it. We have the CDC website and the state health website for Wyoming. We will include those links on Schoology, so you can always keep an updated tab on the change that we are experiencing with COVID-19. So what is COVID-19? Well, COVID is abbreviated for coronavirus, and 19 refers to the year that it was discovered. This was discovered in late 2019 initially, and so that's why we have the name COVID-19. COVID-19 is a newly mutated coronavirus. You will hear the news say things such as, this is a novel virus. That's just meaning it is a new mutated coronavirus. COVID-19 has not been previously seen in humans, so all of this reaction that we have is because we have never seen it affected humans before, and that's why they're trying to take it seriously and make sure they understand it thoroughly, because it hasn't been seen, and so everything is a learning experience. Again, it goes into the unknowns. So that is why we're seeing some of the things we are seeing in society today. COVID-19 is not the same as other forms of coronavirus that causes mild illnesses such as colds and flus. It is much more serious, and we're going to talk a little bit along how we have ways to prevent it and some treatments for it now later on in this presentation. But right now, the biggest difference is that it is not the same as other coronaviruses. It is new, and we need to take it seriously. How did COVID-19 arise? Well, data from scientists suggest that COVID-19 occurred the same way past coronaviruses originated from animals than to humans, which is known as zoonosis. That's a term that you guys can write down and keep in your notes if you want to, but I would suggest that this is a term you would need to know when you're talking about COVID-19, because zoonosis is a disease which can be transmitted from humans to animals or animals to humans. The point about it is it can go from either or. And what happens is that is a mutation of the virus, and it goes from bat to Pangolin to human. That is how COVID-19 happened. Is COVID-19 mutated from a virus affecting a bat first, and so it was originally affecting this bat. The virus mutated and spread to what they believed was a Pangolin, which is like a little armadillo. I put a picture up here in the slide so you can see what they look like. And then the Pangolin spread it to humans. And so this virus has been mutated and took a zoonosis pathway, causing humans to be affected, or humans to be infected after the virus has mutated from animals. Coronavirus historical background. So I wanted to give you background about coronaviruses that we have had before. We are not new to any of the coronaviruses, but COVID-19 is new to us. So it is believed that COVID-19 occurred the same way past coronaviruses originated from animals to humans, that zoonosis pathway that we already talked about. SARS, which happened in 2002, which is the severe acute respiratory syndrome, it was believed that the virus first occurred on a bat, mutated, then affected a civet, and then that mutated and affected humans. The case fatality rate for SARS was 800 people died of the 8,000 affected by SARS. So that's only a 10% case fatality rate, which is very low considering the numbers that we are seeing today with COVID-19. Fast forward to 2012, Middle East respiratory syndrome, which is known as MERS. The virus first affected a bat, mutated, and then affected a camel, and then it mutated and it again took that zoonosis pathway and affected humans. Now the case fatality rate was higher than it was with SARS. The case fatality rate was 34%, which meant 850 people of the 2,500 people died from MERS. Fast forward to today. COVID-19 mutated just like SARS and MERS to affect humans. COVID-19, we again know it first started on a bat, or mutated and believed to affect a Pangolin, and then that has mutated and affected humans. Now our case fatality rate percentage is low compared to MERS and SARS, but the numbers are higher overall. So we have had a higher amount of people die. So far we've had 5,735 people die from COVID-19. And we had a higher number of cases seen with COVID-19. We've had 153,517 cases of COVID-19. So yes, it's higher than SARS and MERS, but the case fatality rate is only 3.7%. So when we have this historical background and we're comparing it to SARS and MERS, that is what we are talking about. Why is COVID-19 so important? Again, it is novel or new. It is unknown. Yes, we have SARS and MERS to compare it to, but it itself is new and unknown. It still needs to be taken seriously. This is why we're pushing this forward and giving you all this information so that society doesn't need to overreact. So stop hoarding all the toilet paper. It's not going to do you any good. It's affecting other people. Don't overreact. Just take it seriously, but don't underreact. When we talk about quarantining and staying home, there's importance for that. You can see in this picture over here with all the medical professionals who are essential personnel. They are exposed to this every day, and they want you to stay home so that we can help stop this and help the prevention method of COVID-19. So don't overreact, but don't underreact. Stay home, help to stop the spread of virus. It is still a virus, and that makes it a communicable disease. So communicable diseases will spread when having the opportunity for exposure. This virus will spread if we keep it exposed. That's why it's important to stay home and take this seriously. The spread of COVID-19. COVID-19 is spread by two routes. The first route is airborne respiratory droplets, so coughs and sneezes. When you cough, you have little respiratory droplets that get expelled and they are spread through the air or they land on surfaces. Now, same with sneezing. When you sneeze, these respiratory droplets come out of your mucous membrane, so your noses or your nose, nose or your mouth, and they get aerosolized and become airborne, or they land on surfaces like counters or chairs, couches, stuff like that. And so that's why the airborne respiratory droplets can spread COVID-19, because they can be breathed in by others, or the touching surfaces like, countertops, couches, stuff like that. That's how it's also spread. It also goes into, if you cough into your hand and then touch something, that also spreads it. The infection rate of COVID-19. The infection rate of COVID-19 is 2 or 3 people who have come into contact with an infected person, then are exposed and or infected, which has an exponential effect on society. So let's say, excuse me, I'm infected. I'm not, by the way, but I am infected and I go have coffee at Starbucks, even though it's closed right now, but let's just say it wasn't closed and I'm in Starbucks and I'm sitting in there and there's 10 people in there. 2 or 3 of the people that are in there with me will have been exposed to this and have the potential to be infected as well. So once I cough or sneeze and get those respiratory droplets out and everything, 2 or 3 people will come into contact with those droplets, and they'll have them come into contact with their mucous membranes, like their mouth, their nose, their face. That's that T-zone on your face that we have talked about, where if you draw a line across your eyebrows and then down to your chin, down your nose, that's that T-zone. So it makes a T, and that's where your mucous membranes are located. So those respiratory droplets are spread on a surface. You touch a surface, you touch your face. That's one way to do it. Or those people happen to walk in to the chunk of air that I just sneezed in. They can be affected by that. So I have now just infected 2 or 3 people. Well, each of those 2 or 3 people affect 2 or 3 more people, and so on. Okay, so here is a visual for the infection rate of COVID-19 that I just talked about. One person, which you can see is the red person, coughing or sneezing at the very beginning of this bracket, they affect 2 people, and then those 2 people each affect 2 people, which now has been 6 people from the original host been affected. Well, then that progresses again exponentially, and that those people affect 2 more and 2 more. So in the end, you can see this bracket, how many of these people have been affected versus just one person infecting them. So that exponential spreading of it because of cough and sneezing and those respiratory droplets getting to other people and affecting them and or infecting them, how exponentially quick it's growing. And that's why we are trying to take it very seriously and cut down on being in contact with other people right now. Okay, so I was trying to find a graph of corona cases in Wyoming, but we don't have one yet. And I found this one instead, which I thought was a great visual for you to see the exponential spread of COVID-19 with the positive cases that we have had in the Midwest. So beginning down here at 0 in the left corner, Wisconsin had a few cases, but then go to March 9th and that's when Minnesota, Iowa, North Dakota, and South Dakota started having some show up too. Fast forward over to another week, March 16th, all these states are starting to have a case, and Wisconsin starts to exponentially grow. Fast forward another week, March 23rd, everybody has cases now, but Wisconsin has totally shot up, followed by Minnesota, and then Iowa and North Dakota, and then fast forward 1 week, March 30th, you can see from March 23rd, Wisconsin had 500 cases to 1,205 cases of positive tests for corona or COVID-19. You can see that exponential growth, big time right there with Wisconsin, and that goes back into one person affecting 2 people, those 2 people affecting 2 people, and so on. So that exponential growth here you can see in this graph. So I wanted to take a minute and talk about the biological mechanisms of COVID-19. And I believe this is important because you're in biology right now, and it's important for you to have a scientific background of COVID-19 and how it's spread. So COVID-19 is carried by pathogens. The route we call it is pathogenesis, which is the manner of development of a disease. So when we talk about germs and viruses and bacteria and stuff, those are all pathogens, and how they're carried are the pathogenesis of it. So that is how it's transmitted, is through pathogenesis. COVID-19 has been identified with the pathogenesis route affecting the RNA of the host. And I have a great video that you're going to see here on the next slide that we come back to protein synthesis, which we talked about in Unit 6.3. And so we're going to take that previously learned material and apply to COVID-19 and what we know today. Because remember, we went through protein synthesis, transcription, translation, how RNA translates proteins and everything in the ribosomes and go forward. That material that you learned in 6.3, that unit that we did, is now being applied to this COVID-19 pandemic that we are experiencing.
If you guys remember from when we talked about in the video in COVID-19 where we went over the pathogenesis, we're going to briefly recap that, right? So again, you have that ACE2 receptor, which binds to the S spike. Okay, so the S spike on the actual SARS-CoV-2 virus, right? When it binds, it then gets taken into the cell and brought into an endosome, right? From there, it's going to release the single-stranded RNA into the cytoplasm. From here, that single-stranded RNA, that positive sense RNA, right? Positive sense single-stranded RNA is then going to get translated by the host cell's ribosomes. Now, once it gets translated, what happens with that? So we're going to lead to translation. What is translation? We're taking the RNA and making proteins. So now what I'm going to do is I'm going to make a bunch of polyproteins, which we're just going to highlight here with specific colors here. We'll draw here's a green polyprotein, here's a black polyprotein. We'll do a black polyprotein, right? And then we also have a pink polyprotein. And we'll just do one more for the heck of it here. We'll have a little blue one. Okay? Now, from here, these polyproteins, what happens to them? Well, remember there's a specific enzyme, right? Called proteinases, which are basically proteases. What they do is they break down these polyproteins into the different units that are going to be making up the capsomeres, making up the nucleocapsid, making up the spike proteins, certain enzymes that are important for the virus. So again, what are these enzymes here called? They're called proteinases. Okay? They're basically proteasomes, right? So they're basically going to be breaking down these polyproteins into smaller proteins. Then from here, we have all these different proteins which are components of the virus. What do we do here? There's another enzyme. You guys remember this little cute enzyme? This enzyme is called RNA dependent RNA polymerase, right? And what does this guy do? He takes this positive sense single-stranded RNA and actually polymerizes it into making more RNA. So now I'm going to take single-stranded RNA, convert it into more single-stranded RNA, positive sense, and then guess what I have now? I have all the components I need to make my virus. Now what I can do is I take my positive sense, single-stranded RNA, combine it with the nucleocapsid, the enzymes, all my spike proteins, and then go ahead and release this virus, rupturing the cell and popping out little baby viruses that can go and infect other nearby cells. So now that we know this mechanism, right? Remdesivir, guess what he does? He inhibits this enzyme. So if remdesivir is actually going to be inhibiting this enzyme, remdesivir, it's going to inhibit this RNA-dependent RNA polymerase. Can you make more single-stranded RNA, which is going to be a component to making more viruses? No. So that's one thing.
Okay, so to recap that video, the pathogenesis of COVID-19, here's a summary I put together for you guys. The ACE2 receptor on a cell binds to the S spike of the virus. That S spike gets taken into the cell. This is released the single strand of RNA into the cytoplasm. From there, that RNA gets translated by the host cells in the ribosomes. Remember, translation that we talked about with protein synthesis? That's where RNA makes those proteins. So going back to what we've already learned with biology, translation is where RNA makes those proteins, and that is how it gets replicated and those enzymes get pushed out with this virus. Well, this virus allows the RNA proteins to make these proteins, and these proteins make multiple proteins or polyproteins, which is multiple proteins. These polyproteins get broken down by proteinases into these smaller proteins. Those get converted into more single-stranded RNA to make viruses, and then once those viruses are made, they get released into the cell and rupture with the cells being infected by the virus. And so, like in the video, we were talking about one way for to treat this, and there's several drugs out there. One pharmaceutical way, though, that he talked about in the video was remdesivir. Remdesivir is a pharmaceutical drug that they're taking, and it inhibits that enzyme production. And what does that do? That ends up making that RNA polymerase to be stopped, which causes those single strands of RNA to not get made anymore, and that keeps down those proteins from being made and being ruptured and having that virus spread. So remdesivir right now is one method that we have for treatment. There are others out there, but honestly, that video could have been a 45-minute video, and there are several videos on YouTube that different people are making that we watch in class and stuff. They're trying to give you guys a background of COVID-19. Those are great resources. If you ever want to know where they are or anything, shoot me an email, because every day there's more going up, and so the list of them are super long, but I would love to share that with you guys so you understand the biology with the pathogenesis of COVID-19 and some of the treatment options that they have. But right now, remdesivir is our best bet with treatment of the pathogenesis of COVID-19. So I know many of you guys are sitting out there going, oh my gosh, Miss Wright, why are we talking about COVID-19? COVID-19 doesn't pertain to me. Well, unfortunately, it really does. The thought of just because I'm not old, it won't affect me is very untrue. It's not necessarily true with scientific evidence that just elderly people are affected. No. In fact, today on the news, I just heard that there was a 10-month-old baby in the South that passed away from COVID-19. So it is affecting others. Yes, it's rare to be in a younger population, but it is affecting others. So I wanted to take a minute and talk about COVID-19 and how it does pertain to you guys. just because the mortality rates are higher for people in elderly ages doesn't mean that you shouldn't respect the severity of COVID-19 and respect the precautions and everything we have put into place as society to help keep it from spreading. COVID-19 can infect younger populations. Where my parents live is outside of Scottsbluff, Nebraska. Scottsbluff, Nebraska's first case of a positive test of COVID-19 was a 30-year-old male. And the paper listed all these places that he had been. Thank goodness my parents, who are in their late 60s, took it very seriously, and they have been staying home because all the places that my parents go are places that he visited. And they asked him where he had been for 30 days because this is going to affect the panhandle of Nebraska. And again, it exponentially grows. So they're worried about how quick this could affect the panhandle because one person who did not self-quarantine, and he was younger, he thought, I'm not old, it's not going to affect me, kept going out and everything. Unfortunately, he became infected. He's the first positive case in Scottsbluff, Nebraska of COVID-19. So yes, it is important. Again, these are rare instances affecting younger population, but it does happen. So why is it important, and why are we taking such precautionary measures to stay home and make you guys feel like you're isolated? Well, because we want you to be careful and be aware of how potentially dangerous this virus truly is for you and your family members. Trust us, I would much rather be back at school with you guys, and I know everybody else would be too. But we don't want this to wipe out our population and affect everybody. So that's why we're doing what we're doing. COVID-19 prevention methods. The most important prevention method, let me just say that louder for those of you in the back, the most important prevention method is social distancing and self-quarantine. As you can see in these pictures, my son and I are staying home. So we can decrease the exposure to other affected individuals, decrease the exponential growth of COVID-19. And even though we aren't experiencing any signs of symptoms or of COVID-19, doesn't mean that the people we come in contact with are or are not. These symptoms are delayed and seen. So you can already be infected with it and not have known and come into contact and exposed it and spread it. Again, going back to that exponentially spreading of that disease comes from not social distancing, not self-quarantining, and helping increase that exposure of the virus. So the most important way to keep COVID-19 manageable and under control is by self-quarantining and staying home, social distancing yourself. We are doing it. As you can see, my son and I are working from home, making the phone calls, working on Zoom, all of that good stuff. We're doing it because we want to keep everybody safe, including all of my students, all of our family, our friends, and Laramie themselves. Wash your hands frequently. Oh my gosh, wash your hands. That's simple. We've talked about that in class. Just wash your hands well with soap and water. Don't touch others' hands. Again, going back to that respiratory droplets. And it could be on surfaces, so don't touch a surface and touch your face. If you have to touch your face, wash your hands. But the important is to be mindful of this and take these precautionary guidelines very seriously and these prevention methods seriously, because we want to keep this disease manageable and stay ahead of it. So most importantly, stay safe.